Hi everyone and welcome to the learning curve. In this video I will be continuing my installments looking at SBAC preparation questions in mathematics for 8th grade students in middle school preparing for their SBAC high stakes examination. Here we are first told that a farmer can harvest 3,150 pounds of potatoes in 7 hours. If the farmer maintains a constant rate, what is the unit rate of harvest in pounds per hour? So what the unit rate is going to tell us here is for every 1 hour spent harvesting potatoes, how many potatoes can be harvested? In other words, in general, the unit rate tells us for every 1 unit of the independent variable, that is the x value, which in this case is time or hours, how many units of the dependent variable y, which is pounds of potatoes rather, can be achieved or harvested in this case. So all we're going to do here is that we're going to divide the dependent variable value, which is the pounds of potatoes that can be harvested, by the number of hours spent harvesting x. So this is going to be 3,150 potatoes divided by 7 hours spent harvesting. And this gives us an answer. When we divide 3,150 by 7, we get 450. What this 450 tells us is that we can get 450 of the numerator value y for every 1 unit of the independent or denominator variable x, which is what the unit rate tells us. So this 450 therefore represents 450 pounds of potato per hour, per 1 unit, which is why we call this the unit rate. All right, so per 1 hour, or for every 1 hour spent harvesting, how many pounds of potatoes can actually be harvested? So this is 450 pounds per hour, and that's our unit rate. Answer is C. In the second question, we are asked, which equation represents a proportional relationship? Now, a linear equation represents a proportional relationship if it takes the form y equal kx plus 0, which means that the y-intercept is actually 0. So if a linear equation takes this form where k is a constant coefficient for x and the y-intercept value is 0, so I could have just stated this as simply y equal kx or y equal mx. So this is another way in which I could state it. It means as well automatically that the y-intercept is 0. So when a linear equation takes this form, then the y-intercept is 0, it means that it is a proportional relationship. This is not proportional because the y-intercept is not 0. This is not proportional because the y-intercept is not 0. In this case, the y-intercept is 3. In this case, the y-intercept is -1. What we're looking for is an equation which has a y-intercept of 0. So either 0 will be stated explicitly as the y-intercept, or it will not be stated at all. K is the constant coefficient of x, or the slope. That's what k here represents. The power of x must be 1 because it's a linear equation. There's an invisible power of 1 here. It's an invisible power of 1. But it's not. That invisible power is generally not stated. In order for the equation to be linear and therefore depict a proportional relationship with a y-intercept of 0, then the power of x must be an invisible one. So the answer can't be A and it can't be D because those y-intercepts are not 0. They are non-zero values. The answer can't be C either because the power of x is square. It's 2, which would mean that this is a quadratic function or a parabola. So it can't be that either. So the answer is going to be B. You realize that this takes the form y equal kx, y equal a half x, is indeed representative of a proportional relationship where the slope k or m is equal to 1/2. Clearly, because the y-intercept, there's no y-intercept stated here, so the y-intercept is 0. It takes this precise form. So the answer is B. Let's go to number 19. Number 19 here says, which of the following graphs represent a proportional relationship between the variables x and y? Always remember that y is the dependent variable and x is the independent variable. The dependent variable y relies on the other variable for its value, while the independent variable x stands alone and has some influence or some impact. It affects the dependent variable y. Y relies on or is affected by x, so that's why y is called the dependent variable. Now, the relationship between two variables is proportional if the y-intercept is 0, as I indicated earlier. So this is a similar question to 18. The concepts are similar. If the y-intercept of a function is 0, then it means that the relationship between the two variables is proportional. If the y-intercept is 0, it means that the graph passes through the origin, and the relationship must be linear, which means that it must be represented by a straight line. So let's examine each of these options. A says a straight line that is horizontal and passes through the point 3, 7. So if a line that is horizontal and passes through the point 3, 7, then this cannot be a proportional relationship because it would not have the 0, 0 point, that is the origin, as its y-intercept. So that cannot be the answer. It says a curve, option B says a curve that starts at the origin 0, 0. This would have been correct if it said a straight line that starts at 0, 0. Because for a graph to represent a proportional relationship, it must pass through the point 0, 0, and it must be a straight line. A curve is not a straight line, so even though this passes through 0, 0, that cannot be the answer. So that's out. C says a straight line that passes through the points 2, 4 and 4, 6, but not the origin. If the graph of an equation does not pass through the origin, that is the 0, 0 point on a graph, then it can't be a proportional relationship between x and y. Let's look at D. D says a straight line, so condition met. Firstly, it's a straight line that passes through the origin 0, 0. It doesn't matter which other point it passes through, as long as it's a straight line that passes through the origin, that is the 0, 0 point, which means that the graph actually has a y-intercept of 0, then it means the relationship between x and y is proportional. So the answer is D. All right? So D is our answer here, D. All right, let's go. Let's look at the last question in this installment, which is question 20. The table shows the distance D a car travels over time t. What is the constant of proportionality in miles per hour for this relationship? So the table shows the distance D a car travels over time t. What is the constant of proportionality in miles per hour? So we can represent the constant of proportionality, K is our symbol for the constant of proportionality, as the constant change, this triangle means change, delta, which means change, as the constant change in y, which is the dependent variable, divided by the constant change in x, which is the independent variable. So this is one way in which we could calculate the constant of proportionality. the constant of proportionality, which exists for proportional relationships, suggests that as the independent variable x changes by a particular value, then the dependent variable changes by a constant value each time the independent variable changes by a constant value. So the change in y here, we're moving from 100 to 150, which is a change of 50. And then we move from 150 to 250, and that gives us a change of 100. Then we look over here and we realize that we move from 2 to 3, which is a change of 1, and from 3 to 5, which is a change of 2 units. So what this means is that the change in y for every 1 unit change in x, y here would be distance, because distance traveled depends on time taken. So time would be our independent variable x, which has an impact or influence on our independent variable y. So what we realize here is that for every one unit change in time, for every 1 hour traveled, 50 miles are covered. How do we know that? Well, what I'm going to do here is that I'm going to divide each of the distances by the time to show you the point. So I'm going to divide each of the distances traveled by the time taken. If it is that we have a constant result, then it means that the relationship is proportional, and that constant result is my constant of proportionality. So let us divide distance traveled by time taken, which is the same as saying y divided by x for each of these. In the first instance, we traveled a distance of 100 miles, and that took us 2 hours. So that gives me an answer of 50 miles per hour. 50 miles per hour, I can write it like that. In the second situation, I traveled a distance. So remember, it's distance divided by time taken, which is the dependent variable divided by the independent variable. So in the second instance, we traveled 150 miles, and that took us 3 hours. So 150 divided by 3 is also 50 miles per hour. So when you have a situation like this where you have coordinates for the dependent and independent variable, and you're asked to determine the constant of proportionality, all you need to do is to divide through the dependent variable values, which are the distance values, by the corresponding time taken. And if you get a constant value, then that value is the constant of proportionality, which is saying that for every 1 unit of the independent variable, which is time, whatever result you get is the amount covered for the dependent variable. Let's look at the third installment here. When 250 miles are traveled, d divided by t, when 250 miles are traveled, it takes 5 hours to do so. When we divide 250 by 5, we realize that we still get 50 miles per hour. So that 50 miles per hour is B. That represents the constant of proportionality, K. And the fact that when I divide the dependent variable values, distance, by the corresponding time taken in each case, I get the same result, is an indication that the relationship between x and y, or in this case specifically distance and time, is indeed proportional. So the answer is B. So thank you very much, everyone. I hope you found this lesson to be extremely useful, and I look forward to you tuning in for much more as we continue this special journey in the learning and mastery of mathematics. Thank you.